Vector and matrix algebra 4. Let D be a 2 by 2 square matrix and V is a 2 by 1 column matrix. Determine the conditions imposed on D by the requirement that the transpose of D times V is V transpose times D for any V. Alright, so first of all, let's remember that the subscript summation notation representation of the matrix elements for D matrix can be written as Dij, where I and j are now 1 and 2 because it's a 2 by 2 matrix. And similarly, for the V matrix, I have this is a 2 by 1 column matrix. The matrix representation can be written as V sub j is equal to 1 and 2. And in matrix notation, this implies that I have D11, D12, first row, second column, D21 and D22, second row, second column. This is my D matrix, which is a square matrix. And V is a column matrix. Remember, it's a 2 rows, 1 column matrix. So we're going to have V1 first row, first column, and then second row, first column. So V1, 1 and V2, 1. This is a column matrix. All right. Now we're looking at the multiplication of D matrix with V matrix. So if I pre-multiply V matrix with D matrix, using the subscript summation notation, this can be written as Dij Vj. And there's a summation over j. And if I take the transpose of this, V matrix pre-multiplied by D matrix, and I'm taking its transpose, this is going to give me, you have to switch the places of the rows and columns, so it will be Vj, and I have so for this one here, I could just use V1 and V2. And then column matrix and row matrix, they will have the same index. And then here I have Vj, D, Ji, because I and j have switched places. Okay, now if I do V transpose times D, so because I'm using only one index here, that has the same representation in a subscript summation notation, Vj multiplied with Dij. So what do I find? I find if these two are equal, Vj Dji must be equal to Dij, Vj. All right. So this implies that because Vj's are the same here, Dji must be equal to Dij. So this implies Dij must be equal to Dji. And this is for I and j values 1 and 2. And let's see this explicitly. Now I have D matrix multiplied by V matrix. V matrix is pre-multiplied by D matrix. This is D11, D12, D21, D22. Since V is a column matrix, I only need one index. V1, V2. And this gives me a 2 by 2 matrix multiplied by 2 by 1 matrix gives me a 2 by 1 matrix, 2 rows, 1 column, which is D11V1 plus D12V2, D11V1 plus D12V2, and then I have second element D21V1 plus D22V2. All right, now I take the transpose of this answer. So D matrix B matrix B pre-multiplied by D matrix transpose is basically when I have to exchange the rows and columns. So this is going to become now a row matrix. So this will be D11 V1 plus D12 V2, and second element is D21 V1 plus D22 V2. That's the transpose. Now let's look at V transpose times D. We take the transpose of the column 2 by 1 column matrix V, and D is pre-multiplied by V transpose. This gives me V1, V2, it's a row matrix, multiplied by D11, D12, D21, D22, and that's going to give me a 1 by 2 by multiplied by 2 by 2 will give me a 1 by 2 matrix, which is a row matrix. So it will be V1 D11 plus V2 D21, V1 D11 plus V2 D21, second element V1 D12, V2 D22, V1 D12 plus V2 D22. Now I'm supposed to compare these two answers. If I do, I find that for them to be equal, the elements D11V1 plus D12V2 should be equal to V1 D11 plus V2 D21, and the second element D21 V1 plus D22 V2 must be equal to V1 D12 plus V2 D22. Now you can see that these terms are already equal, so they cancel out, and these terms are already equal, so they cancel out. So I find that this implies D12 must be equal to D21, and this also implies D21 must be equal to D12. So my conclusion that Dij must be equal to Dji is correct. In other words, we can say that when I and j switch places, that means we're taking the transpose of the D matrix. So D matrix must be equal to its transpose. That's the requirement for this equation to hold. Okay, so in this problem we have a 2 by 2 square matrix multiplied by a 2 by 1 column matrix, D times 1. And if I take the transpose of the multiplication, that is V transpose times D is equal to V transpose times D, then this imposes a requirement on D. Normally, I know if you take the transpose of this, you get V transpose times D transpose. So this immediately implies D must be equal to D transpose. So let's see that. So D is represented in subscript summation rotation as Dij, and V is a single column matrix, so it is Vj. So Dij Vj is D times V, and dV transpose will be Vj Dji, and V will turn into so basically, we're switching the places of I and j here. That's what we're doing. V transpose times D. V transpose is Vj represented by Vj, and D is still Dij. So Vj Dij must be equal to Dij Vj. Vj Dij must be equal to Vj Dji. That's what I see here. So this implies, because the Vj's are the same, Dij must be equal to Dji. In other words, the matrix must be equal to its transpose. So here we have explicitly shown that by looking at the elements of the equation, dv transpose elements and also v transpose d elements, the requirement is d12 equals d21, which means dij is equal to dji, as we have found out.